Let us discuss a program which will print the message hello world n times. Let n equal to 10. The algorithm is how we will be keeping a variable count equal to 0, and for that we will be using CL register. When each time the message is printed, we will increment the count. Then we will compare this count against n. When they are equal, that is n and count are equal, stop printing the message. Then here goes the data segment. Its name is my data. Inside this message 1 is declared. DB means defined byte. Hello world in assembly language 8086 assembly language. A string ends with a dollar symbol. Then n is the this much times we have to print n db defined byte. Then we have stored 10, value 10 in variable n. Okay. Then here is the end of the data segment. Code segment starts. The name of the code segment is my code, and the first statement inside this code segment is assume cs colon my code comma ds colon my data, through which we are saying or directing the assembler that assume is an assembler directive. We are directing the assembler that there is a segment called my code, and it should be used as the code segment of the program, and the segment named my data, that should be used as the data segment of this program. This is the label assigned to the first executive instruction, move as comma my data. Then after that move ds comma x. Okay, we have used these statements to initialize ds register, data segment register. We can't move a value directly to any segment registers, so we are taking the address of my data, that is the data segment, to AX register, then moving the content of AX register to DS. Okay, then as we have mentioned, CL, it is the count, it is 0 initially. Then these statements move ds comma offset to msg 1, move ah comma 09h and int to 1h. These three lines will print the message msg. The requirement of this function number 09 of DOS interrupt is the offset of the message to be displayed should be there in dx register. Okay, then after printing we will increment CL. Okay, you can see here push CX. This is done for protecting the value stored in CL register. Okay, because an interrupt call may change the register contents. Okay, so that is the reason why we have kept this move ds comma offset msg inside the iteration. Okay, so every time we are moving the offset of msg1 to dx, because there is a chance that int to 1h, the call of int to 1h may alter the content of dx register. Okay, to avoid that, we are keeping this move dx comma offset of msg1 inside this iteration. Then after incrementing CL, that is once the message is printed, we will be incrementing CL content, CL equal to CL plus 1. Then we will compare CL against n. When CL is less, that is a message is not printed n times, the control will be transferred to the label again print. Okay, here you can see the label again print. Okay, this is a backward reference. When CL equal to n, we will be terminating the program, and these two statements move ax comma 4c 00h and int to 1h will terminate the program. This 4c is the function number, 00h in AL, it is the return value, and these are the requirements of DOS interrupt to 1h for terminating the program. Move ax comma 4c 00h means 4c will be in AH and 00 will be in AL. int to 1h is the DOS interrupt call. We are using the function 4c of DOS interrupt. Its requirements are A should contain the function number and AL should contain the return value. So this is the end of the physical end of the program. Okay, and we have specified the label start, the label assigned to the first executable instruction. Let us translate this program. For that, DOS box, here you can see this message hello world is printed 10 times.